So every time we were in the what unit was it that we had to always change to degree mode? Trig. When we were in the trigonometry unit, it was important that we were in degree mode. And there was another mode on our calculator, and we didn't know what it meant. It was called radian mode. Well, today we're going to figure out what a radian is. A radian is another way to measure an angle. That's why it's called radian measure. So this angle might be 60 degrees, but we're going to find out what an angle is in radians today. And you'll actually find in pre-cal that radians are a lot easier to work with in trig than degrees are. So, really cool. We're going to be connecting this to what you're going to learn in pre-cal. These were the supplies that we wanted to gather. And we're going to look at Sketchpad first. So looking at Geometry Sketchpad, we have an angle already constructed here. What is the vocab word for that angle? What kind of angle is that? Because it's very important what kind of angle it is. It's a central angle. Yes. Okay. Circle vocab word. That is a central angle. Now, we want to ask ourselves, could we move point B? Notice the angle gets smaller, the measure of the arc gets smaller. The angle gets larger, the measure of the arc gets larger. Could we move B so that AC, stop right there, what's AC? What's the vocab word for AC? The radius. Could we move it to where the radius equals the measure of arc AB? Have we ever talked about a straight segment equaling a curve? I've been so adamant about telling you segments don't have pi in them. Curves do have pi in them, but pi is just a multiplier. It's just a number. So what we're trying to figure out today is if I can make that radius equal the length of my arc. Can I make R equal L? That's what it's saying. Can I make R equal L? Well, let's see right now. AC is 4.69. You see that? The length of the arc is 3.96. So what should I do? I need to make that catch up. The radius isn't moving. The arc length is. Ooh, am I there? Am I there? Am I there? No. Are you watching? Oh, did I get there? It's like stuck. I need 6.9. Close enough. We're going to go with, I had it. Okay, you don't need to watch me do that anymore. So anyways, I'm, what, 1/100th of a point away. So I forced AC, the radius, to equal the arc length, the length of the arc. So we're going to find out what happens when the arc length equals the radius. How many times would the arc length equal the radius? How many locations of B would they be equal? 2. How many different places could I put B? What happens if I do this? Uh-oh. Look, they're not even close. 4.69, 27. How many locations of B could make those two things equal? The answer is, I can't get there. The answer is 1, right? There's only one location. I can put B in one spot that would make the length of the arc equal the radius. One spot. Good job. Okay, now we're going to go to page 3 of Sketchpad, but you're also going to get your circle out, and I want everyone to draw the radius of their circle. I want you to connect the center to the circle with a straight edge. It doesn't have to be a ruler, just anything that's a straight edge. Once you've drawn that radius, I want you to take your string or your dental floss or your pipe cleaner, and I want you to measure how long the radius is, and I want you to cut the dental floss or the pipe cleaner the length of the radius. I want your manipulative to be the same length as your radius. Next, I want you to take this manipulative, your floss or your string. This is your radius, right? And everyone's might look different because we all got different circles. I want you to take this, and I want you to put it along your circle. I want you to bend it to go along your circle. And I want you to draw the angle that intercepts the arc, if that makes sense. So you're putting your pipe cleaner along the circle, and then you're drawing the angle that opens up to the curved pipe cleaner. So you drew the radius, you cut a manipulative the length of your radius, you curved that radius around your circle, and then you drew an angle, a central angle that opens up to an arc. And that arc is the length of your radius. Now, if you have patty paper, I want you to take your patty paper and I want you to trace the angle. If you do not have patty paper, you can try to trace it just using a normal sheet of paper, hold it up to the light and see what you can do. I want you to trace your angle with patty paper. You're going to have that central angle drawn on a sheet of patty paper. If there's more than one person at your school, I want you to compare your angle to everyone else's and see how your angle compares to their angles. What's really cool about this is that when you compared to everyone else who did the same thing, even though their circles were different sizes, there were 6 different circle sizes out there. Even despite the size of your circle, despite the length of your radius, you came up with the same angle. This angle is a very, very special angle. I haven't told you to measure it yet, and you're not going to yet, but this angle is the key to today's lesson. Let's keep going. Now, when you took that radius and that pipe cleaner, that dental floss, and you wrapped it around your circle, you forced the radius to equal the arc length. You forced the radius to equal the arc length. Now, your radius might have been 3 inches, and the arc length might have been 3 inches. But when you write that as a proportion, so it doesn't let me write on here, but if you write that as a proportion, let's see if it will. No? Okay. Then you're going to get 1. The proportion of the arc length divided by the radius. You force the arc length to equal the radius. Therefore, you have a ratio of 1. Arc length divided by radius. So you can write that down in your notes. That is actually what a radian is. It is the arc length divided by the radius. So go ahead and write this in your notes. A radian. The ratio of the length of the arc intercepted by a central angle and the radius of the circle. AKA, radian is L over R. It is a comparison. It's a ratio. It's a fraction. It's a division. It's a quotient. All right, here's another good slide. I kind of already wrote this on the other slide. I got ahead of myself. The radian is the arc length, cursive L, divided by the radius. The angle that we created has a measure of 1, and that is weird. It's not 1 degree, it's 1 radian. So we haven't measured it yet in degrees, okay? So don't do that yet. But the angle we created with our dental floss and our circle, the measure that's the same for everybody, this is 1 radian right here. Welcome to 1 radian. This is it. Dun, da, da, da. It's very special. Good question, Neil. Is a radian a unit or a length? A radian is a measure. It's measuring how much the angle is opening. Good question. It is not a length. But what's weird is that a radian is unitless. Does that make sense? It doesn't have units. So you can put the measure of ABC equals 1 radian, but you're not supposed to because radians are unitless. They don't have units. You just say the measure is 1. And when people just write 1 or 3 or 5 pi, people just assume it's radian. It's like if you don't write it, you assume it. You know, kind of like the 1 is understood. You don't need to write the 1. We don't normally write the 1. Same thing with the word radian. If you don't put a degree symbol, we assume it's radians. So, okay, Neil, in this one, the measure of ABC equals 1. I'm just writing it like I would solve a problem and say it equals 1. And then I wanted to describe it using words. So that's why I described it using words here, and that's why I wrote radian here, because I'm trying to describe it using words. That's a really good question, though. Now we're going to figure out how many radians does it take to make a full circle. So you can take a guess. First, just take a guess. People who haven't already researched it. Once you've taken a guess, I want you to take your patty paper, if you have it, and I want you to go 1 radian and mark it. Go another one and mark it. Do you know what I'm saying? Take that patty paper, go all the way around your circle, and see how many angles you can do. The answer is not 2 pi. So remember, a radian is an angle measure. That beautiful blue thing that just happened, that is what a radian is. Now I want to know how many angles it would take to make a full circle. So you're kind of, oops, oh goodness, I forgot it doesn't let me draw. But it's kind of cool how the fact that this angle stays 1 no matter what I do. You see how I'm moving this? Do you see how the measure keeps equaling 1 over and over and over? Do you also see how the units cancel? 3 centimeters divided by 3 centimeters, the centimeters cancel, and that's why it's unitless. All right, let's do it. Let's see. So I'm going to, right now I have an angle measure of 0. I'm going to move B. That's an angle measure of 1 radian, 1. I'm going to move it again. Maybe. That's 2. That's 3. That's 4. That's 5. Whoa, that's 6. So when you took your patty paper and you went around your circle, you should have gotten 6 and a little bit more, right? It's not quite 7. It's more than 6. It's less than 7. So that's what you should have gotten. Yeah, it looks like Pac-Man. You should have gotten an answer between 6 and 7. Now I'm going to let you measure your angle. You now have permission to measure your angle. Use your protractor and measure. Well, by the way, what units does a protractor use? All these numbers, what are they in? Are they in radians? They're in degrees. Okay, yeah. So I want you to measure how many degrees your angle is, because we already know it's 1 radian. I want you to measure how many degrees you get. We should all get the same answer. When I measured, mine is like about 54 degrees-ish. 56, yeah, I could see that. It's not perfectly precise. So what does 1 radian equal in degrees? Remember that a radian is an angle. It's not how long it is. Let's look and see. So what this sketch pad just did was it just drew in a 60-degree angle. There's a 60-degree angle. You see how a radian is just shy of 60 degrees. And I could move this around, could make it larger and smaller, but it's not changing those angles. So a radian is just shy of 60 degrees, and the answer is actually 57.3. 57.3 is the answer. So you can write that down in your notes if you want to know what 1 radian is in degrees. So are there the same number of radians in every circle regardless of size? So when we try to answer this problem, we need to think about, okay, is a radian an angle measure, an opening, or is a radian a distance of how far we're going? And what's important to remember is that just like in a circle, how many degrees are there? 360. It doesn't matter if my circle's this big or if my circle's this big, there's 360 degrees. Same with radians. So there's 1, 2, 3, 4, 5, 6, and a little bit more. 6.28 radians in a circle. That happens to equal something else. Someone was saying it earlier, 2 pi. Someone was saying 2 pi. Everyone go to your calculator and do 2 times the pi button. Do 2 times the pi button. Oh my goodness. So there are 6.3 radians in a full circle. But 6.3 exact is 2 pi. And that's what I had waiting for us right here. So a radian is the arc length over the radius. What if I want to know how many radians are in a full circle? Then the arc length would be all the way around. It'd be the circumference over the radius. Well, circumference is 2 pi r. What happens to the r's? Cool. So the circumference of a circle in radians is 2 pi. 6.28. 2 pi. I know y'all are stressing out because you may or may not be confused right now. We're going to do this slide. But then on the homework, the main thing that you're going to need is to know that the radian is L over R. That's what you're going to be doing on the homework. The radian is the arc length divided by the radius. And that's all the state wants you to know, the TEKS want you to know. That it is a proportion, it's a comparison of the arc length to the radius. How many radians are in a circle? 2 pi. How many radians are in a half circle? Pi. Yeah. What does 1 radian represent? 1 radian is the angle that is created when the radius equals the arc length. That is a radian. Get it? Radian, radius? It's using the radius and making it the arc length. Radian comes from the word radius. So 1 radian in degrees, remember what it was in degrees? It's a little bit less than 60 degrees. A radian is the ratio of the arc length to the radius. We're going to skip number 5. We can do that as a warm-up another day. True or false? The bigger the circle, the bigger the radian measure. True or false? Good. That's like saying the bigger the circle, the bigger the degrees in a circle. No. The bigger the circle, the bigger the angle. No.